Hello, welcome to another logic unit. So in this unit, we're going to expand our derivation system by adding a new form of derivation. So far, we have one form of derivation, one method of derivation, direct derivation. And in this unit, we're going to add a new one, which we call conditional derivation. In this video, I'll show you conditional derivation in English, and then in subsequent videos, we'll look at conditional derivation in the formal system and some examples with derivations. And we'll also add a little bit with symbolization as well, which we'll see when we get there. So, let's consider an example argument in English first. So you're in the airport and you learn that the attendant tells you, if it snowed this morning in Denver, the plane will be at least 2 hours late. And you also know that if the plane will be at least 2 hours late, I will be too late for dinner, for my sister's wedding. And so these are the two premises, and from this it follows, if it snowed this morning, I will be too late in Denver. I will be too late for dinner. So that's a valid argument, and we would like to be able to derive it in our, we'd like to be able to derive it. But using the rules we've talked about so far, we can't. We couldn't derive this argument. The rules we've talked about in English won't let us derive this argument, and if we symbolized it, we wouldn't be able to do a derivation of the symbolization in our system. So let's look at why that is. So here's kind of a compression of the argument, just with shorter sentences. So the first problem is that we can't really use the premises. So what are the premises? They are, if it snowed, the plane will be late, and if the plane will be late, I will be late. So the antecedent of the first premise is, it snowed. The antecedent of the second premise is, the plane will be late. Okay, now, do we have it snowed as another premise? We don't. Do we have the plane will be late as another premise? We don't. So we don't have the antecedents of either of the premises. And what about their consequence? Do we have the negations of them? No. The negation of the consequent of the first premise is the plane will not be late. And we don't have the plane will not be late. And the negation of the consequent of the second premise is I will not be late. And we don't have that. So we can't do modus ponens, and we can't do modus tollens with our two premises. We would need to have the antecedent of one of the premises. We don't have that. We would need to have the negation of the consequent of one of the premises. We don't have that either. So there's no MP, there's no MP to be done. No MP, no MT. And in our previous derivations, when we were in a situation where we weren't immediately able to do MP or MT, we were able to use DN and S and ADJ to make the antecedent or to make the negation of the consequent of one of our conditionals. But we aren't in that situation. We apply DN to these and we'll get double negated conditionals, which is not helpful. S doesn't apply because they aren't conjunctions, and we could adjoin the two premises, but then we just have a big conjunction, and that wouldn't help either. So we can't use the premises, and so we can't move the derivation forward. The other problem is it's not clear, even if we could, how we would get to the conclusion. How do you introduce a conditional? How do you add a conditional? We don't know. Our MP and MT rules eliminate conditionals. I mean, again, the conditional premise stays in the derivation, but when we apply MT or we apply MT, we have the conclusion has fewer conditionals than we started with, right? If we have if P then Q, and we have P, we apply modus ponens, we get Q. Q doesn't have as many arrows, it doesn't have any, as if P then Q does. So our MP and MT rules get rid of conditionals, but here the conclusion is a conditional. So how would we get that? ADJ lets us introduce a conjunction, right? If you have P, then separately have Q, you can infer P and Q. You can add a conjunction to what you already have. But we don't have a method for adding conditionals to things that we already have. So how would you get that conclusion? It's not clear how you could. We don't have ADJ or an analog of ADJ for conditionals. So we really have two problems with this argument. First, we can't use the premises because we don't have what we need to use the premises. And second, we don't know how to introduce conditionals. So given just what we've done so far, with the rules we've laid out so far, we could not do a derivation of this argument. But it is a valid argument, no matter what. If the premises are true, so is the conclusion. And we'd like to understand then how we can reason that out, how we can see that in fact it is a valid argument using small, obviously valid steps. Well, conditional derivation is going to solve both of these problems. It's going to give us more to work with besides just the premises, and it's going to tell us how to introduce a conditional, how to infer to a conditional. So if you wanted to convince someone else that this was a valid argument, or you wanted to verify for yourself that it was a valid argument, you would try to reason it out. How would you do that? Well, look at the conclusion. The conclusion says, if it snowed, I will be late. So you might say, well, suppose that it snowed. You'd say, assume it snowed. Well, given that assumption in the first premise being if it snowed, the plane will be late, then you can conclude the plane will be late. This is given the assumption, it follows that the plane will be late. Given the assumption in the first premise, you know the plane will be late. That's just modus ponens. Now, if the plane will be late, we can combine that with the second premise. If the plane will be late, I will be late, and we can infer I will be late. So at this point we know, given the premises and given this additional assumption, it snowed, we can get to I will be late. It follows if the premises are true and this additional assumption is true, it follows that I will be late. Well, that means if it snowed, I will be late. I can argue from the assumption to I will be late, and that means if the assumption is true, then I will be late. Right, so in here we've introduced a conditional. So there's the assumption step, and there's this conclusion where we introduce a conditional step, and those are new. In the middle, it's old. So to spell this out, the first thing we do is we say assume it snowed. So we assume the antecedent. That's new. We haven't done that before. We've had premises. We haven't made assumptions. Then we do our familiar modus ponens reasoning. This is old hat. We've done this before. No problem. We're just reasoning. But where do we get to? We don't get to the conclusion. We get to the conclusion is if it snowed, I will be late. And we haven't reached that conditional. We just have the consequent of that conditional, I will be late. But then what we say is, look, what I can go to if it snowed, I will be late, because I can infer the conditional if it snowed, I will be late from the chain of reasoning. I was able to reason from it snowed to I will be late, and because I was able to do that, I can infer the conditional. If it snowed, I will be late. So the steps in a conditional derivation, we assume the antecedent, we reason to the consequent from that assumption, whatever it is, from the assumption of the antecedent, and the premises. And if we can do that, if we can get from the antecedent of the conditional and the premises to the consequent of the conditional, that means if the premises are true, then the conditional is true. And that means we can infer the conditional. So those are the steps of a conditional derivation in English. In the next video, we'll look at steps of conditional derivation in the formal system.